All right, so grade 12s. We are going to talk about object composition. What are we going to talk about? Object composition. Very good. Object composition. What does it mean to compose? To compose composition. What does composition mean? To make, to create. Yep.
Things are sort of set or organized.
Set or organized. Sure. Where have you seen it? Have you talked about composite shapes? Remember in grade 9 math you did composite shapes? So it's like Sebastian has a pool in his backyard and it's comprised of a rectangle, but on one end he's got like a semicircle and it says find the total area if the dimensions are so and so. Right? Do you remember that? You have to find the circumference and the area of the composite shape. That was a rectangle. Now, a rectangle is length times width, right? A circle is what? 2 pi r, right? For the perimeter. Then you'd half that because there's a semicircle, and then you'd add them together and that kind of stuff, right? So composite shape is putting together shapes. So composite objects are putting together objects. Exactly. So we're going to put together objects. So here we have a 2 by 2 matrix, right? Do you guys remember this 2 by 2 matrix? Right? We did it in our lab. So we did a 2 by 2 matrix. So this is thanks to Livon for sharing her lab with us for us to use in the lesson. So here, this is what we did. We made a 2 by 2 matrix that could represent this matrix right here, right? Like 2.45, 3.127, just random double values, correct? You guys with me? So this is the matrix that you've made. Now what we're going to do is we're going to compose a fraction onto a 2 by 2 matrix. That means instead of using double values, we're going to use fractional values. Now, obviously this is going to be for a different purpose. It might not be for the same reason, right? You might need the double matrix, the matrix with double values for a different reason. You might want the matrix with fractions for a different reason or a different purpose. The fractional one, let's say we wanted because we wanted exact values. We didn't want to deal with rounding or anything like that. So fractions let us deal with exact values. But of course then, the downside is we cannot represent irrational numbers, which we could somewhat, at least in the other version of our 2 by 2 matrix. So it's a different purpose, but it's a good example for doing object composition. So I'm going to go over here to Livon's program here for lab, and what we're going to do is we are going to compose. Ready to compose? Now, we have made this 2 by 2 matrix as what kind of programmer? The primary programmer, right? We made up these terms. Mr. Cardoso made up these terms, primary and secondary programmers. But really, it's oversimplified, and that's not how it works. So, necessarily. So yes, this is the primary programmer of the 2 by 2 matrix, but guess what? We're now going to become the secondary programmer of the fraction class at the same time. By doing this, I'm going to change each one of these to a fraction. Whoa. Now, we've got objects within an object. Make sense? So I hope you guys are paying attention because you're going to have to complete this class for me. Okay. All right, so now we've got fractions within our 2 by 2 matrix. Instead of them being double values, they are now fractions. Now, let's play our favorite game show. Will it compile? Will it compile now with those changes that I just made? No? How many errors am I going to have? A lot. So let's try to compile this. 49 errors. 49 errors. So we got a lot of errors now. We changed it to a fraction. So what I'm going to do, and this is what you're going to do too when you start working on this, because you can do it with your own lab, is I am going to comment out everything just by, if your program is well commented like Livon's is. You just go to the bottom one here, and just remove this, and it will allow you to comment out everything in there. And then we get it to compile, and then we go back and we add everything in by making the adjustments that we need to make. All right, so let's do that. That. Almost there. Almost there. Oh, this program's really long. Almost there. We got some helper methods. We got to do those too. And then let's put this one back in here. Okay, so we've commented it all out now. Let's go back to the top. Okay, so I'm going to compile. And now it compiles, but it does nothing. Okay, so let's go back. Why did it go back to the bottom? I'm not sure. So it compiles now, but it does nothing. Eric, whisper. Okay, so now what we're going to do is we're going to look at this one. Let's put this constructor back in. So what's wrong with this constructor? If I try to compile this constructor, add it in there, I'm going to get 4 errors. And what is it saying? Cannot convert from int to fraction. Yes, go ahead, Paz.
Since everything is a fraction object,
Mm-hmm.
all things are not fraction objects, I think because A is now an object instead of a number, but we're treating it like a number, it does not sort of compute that.
Exactly. So we're trying to put a number like a 0, which is a double or an integer. It's an integer, but before we were putting an integer into a double. That's fine. Now we're trying to put an integer into this dot A, and this dot A is a fraction. So how do you suggest I fix this? Anybody? Yeah, I can go new fraction, use the constructor in our fraction class, and then go 0, 1, for example, or just use the default. Because remember, if I go to my fraction class here, I should have a default constructor that sets it to 0 over 1, and I do. So that's the new fraction that I'm going to use there. So I'm going to copy and paste this and assign it to each one of these, which will make it 0 over 1. If I want to make it explicit, I can go 0 over 1 like that. But because I know that other fraction, that class does that. So now, does it compile? Yes. So now we've wrapped those zeros into a fraction. 0 over 1, 0 over 1, 0 over 1, and 0 over 1. Make sense? So now this is still a 2 by 2 matrix of all zeros. Now let's test it out. So let's make a 2 by 2 matrix. Let's call it M1 equals new 2 by 2 matrix. Let's just make the default 1 there. And let's print M1. Ready? 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 Oh. We have to put the toString method back in because we commented it out. All right, so let's go down and see what else we got. We also have another constructor here. Let's put this constructor back in before we get to toString. So we have another constructor here that takes in the 4 double values. Will this one work? So compile that. No. Again, we can't put doubles into a fraction. So we could do a couple of things. We could change these all to fraction. Will this compile now? And assign them along. So we can do that. All right, so that fixed that. Cool. Now we want to put our toString back in. Now what do I need to change in the toString method? Round 3 decimals. What does that take in? A double. Is this dot A now a double? It's a fraction now, right? It's not a double. So I can't call this method, but do I need to? Do I need to round it if it's in a fraction form? No, so let's just remove it. So that wouldn't compile with that because it's taking doubles, and now these are all fractions. Now, will this work? I probably don't need all these brackets. Does this work?
Yeah.
All right, so let's compile that. Let's test it now. All right, so it compiled. All right, let's make a new matrix. Now I print M1. What does M1 give me? There I have 0 over 1, 0 over 1, 0 over 1, 0 over 1. Now, again, I hope you appreciate what's happening here when I did that M1. What's happening there in this two-string method? Another two-string method is being called. So it's really cool when we start building objects upon other objects. And that's what I mean. Objects are, it's not just primary and secondary programmers. Now we're actually using the methods from the fraction class as the, so we're the primary programmer of 2x2 matrix right now, but we're the secondary programmer of the fraction class. Yep.
So does that mean that if two methods in the fraction class and in the 2x2 matrix class are the same, if their names are the same, will they, and if they're called in one, will that call both of them?
No, it will know which one to call based on what the object is calling it. So when I say this dot A, right, this, what is the data type of this?
Implicit?
It's the implicit one, but what class am I in right now?
2x2.
2x2 matrix. So this is a 2x2 matrix. Do you agree?
Yeah.
But A, this dot A is what?
Fraction.
A fraction. So when I say this dot A, it's actually calling the two-string method. From this method, it's calling the two-string method of the fraction class. Because this dot A is a fraction, so it's calling the two-string method from the fraction class. Make sense?
Okay.
So based on whatever's before the dot, what is the data type before the dot? Is the data, or actually in this case, what is this whole data type? The data type before the dot is a 2x2 matrix, but then in this context we're saying this dot A, so print this dot A. This dot A is a fraction, so it calls the two-string method of the fraction class.
How does it need to do that?
Sorry?
How does it need to do that?
Just based on what the object is. So what are you trying to print, right? So for example, if I go over here and I make fraction f1 equals new fraction, let's say 3 comma 4, that's going to be a mistake. And I do that, and then I go f1 or f1 dot toString. Remember, we don't have to do that shortcut for two-string methods. We just call f1. So if I go f1, it knows that f1 is a fraction object, so it looks in the fraction class for that method, that two-string method. If I go m1, it knows that m1 is of type 2x2 matrix. It's an instance of 2x2 matrix. So it goes to the 2x2 matrix class and calls the two-string method for that class, which then in turn calls the two-string method for each of the fractions that are involved. Make sense?
Yeah.
So it's cool how it works automatically when you do object composition. Now, if I had written this fraction class a bit better, these 0 over 1s might have turned into zeros. I didn't do that properly in my two-string method here. Right. You can see my two-string method is very simple here. But if I did that, that would be a little bit nicer and show up nicer. All right, so any questions so far? Now, we can also make, what if I want to make a matrix, a 2x2 matrix, but with values? How do I do that? So, Thomas? Method overloading, but don't I already have a constructor like this one? So instead of making like a default, how can I put some new fractions in there? So because they're taking fractions, I can make 4 fractions and then send them in as parameters. That's one option. Or I could do it directly in here like this. So I can just go new fraction. Let's say 1 comma 2. Let's say new fraction. Let's say 3 comma 4. Let's say new fraction. Let's say we just want the number 5. What would I do for the number 5? Just 5 over 1. So 5 comma 1. And then let's say I want 0. So I can just go new fraction, open close brackets, because that's the default constructor, and that creates a 0. Okay, now I print M1. I should have changed it to M2. And I get this. Pretty cool, right? Again, my two-string method is not done there properly, so I'm not getting the 5 instead of 5 over 1 and the 0 over 0 over 1. But that's the two-string method of the fraction class that could be done better. Questions about that? Now, this is also a bit tedious for our secondary programmer who's using the 2 by 2 matrix. Maybe you could think of it as the tertiary programmer now, because there could be like 10, 15 different objects along the route, right? Objects that build upon objects, that build upon objects, that build upon objects. That's why this is called object composition. Now, does anybody have any suggestions for making this shorter for them? See how long that line is? Yep.
Maybe a separate constructor specifically for 2 by 2 matrices.
Yep. So we can make another constructor that takes in basically 8 numbers, because each fraction is 2 numbers, right? So I can go like this. Public 2 by 2 matrix. And this time I'll take in 8 integers. So let's say num A, den A, int num B, int den B, int num C, int den C, int num D, int den D. Okay, so numerator, let me just double check my variable names. Numerator of A, denominator of A, numerator of B, denominator of B, numerator of C, denominator of C, numerator of D, denominator of D. All right, so now I can go here. So just giving the secondary programmer here options. And so now how do I do this? How do I create A? So this dot A, or just A, gets. What do I do here?
New fraction.
New fraction, good. And then what do I put in there? Teach them. Num A, then A, right? And then I'm just going to copy and paste this 4 times. And don't forget to make the adjustments. This is how errors happen in programming. Copying and pasting is fine, but then we forget to change something. And then we're pulling our hair out later, so be careful. So this is B, C, C, and D, and D. Yep. So I compile this, and it doesn't like it. Why not? Oh, we have exceptions, sorry. Let me go over here and deal with my exceptions. We'll talk about exceptions a little bit more and why I'm getting that error. But I'm basically going to fix that here by doing this. Okay, and now it should compile. Okay, there we go. So now, so don't worry about that. That is another lesson on runtime exceptions versus regular exceptions. So now, instead of doing this, so I wanted 1 over 2, 3 over 4, 5 over 1, and 0. Now I can take out all of the new fractions because I got one that just takes in all the numbers. So 1 over 2, 3 over 4, 5 over 1, and let's say 0 over 1. So now that's a lot faster to make that matrix. And now I can go m1, and there I have 1 over 2, so this one gives me 1 over 2. These two gives me 3 over 4. These two give me 5 over 1. And these two give me 0 over 1. Make sense? So we made it a bit more convenient with adding that constructor. So now the secondary programmer doesn't have to go new fraction each time. We take care of the making the new fractions. Questions? All right, let's do one more. We did two-string. Let's go down. Okay, let's take a look at determinants. Let's put determinant back in. Is determinant going to compile as is? No. This dot A times this dot B minus this dot B times this dot C. Yep.
For calculations, would it still return a double or would it return a fraction?
Yes, good question, right? So if you're calculating the determinant of this matrix, determinant of the matrix is this times this minus this times this. So if I go fraction times fraction minus fraction times fraction, what will my result be? A fraction. Fraction times fraction minus fraction times fraction. The result's going to be fraction. So that's the first thing I have to change. Change that double to a fraction. Now, for the determinant. Now, what do I need to do here? Can I multiply two fractions like that? Thomas? What do I do?
This dot A dot multiplier or whatever.
Good. This dot A, I think in the fraction class now, because remember, this is a 2 by 2 matrix, but this dot A is a fraction. So this dot A is a fraction. So I have to go to the fraction class, and it's called times in the fraction class. So this dot A dot times, I can leave out the this dot if that's giving you too much dots, right? But so it's going to be this dot A, which is a fraction. And then we're calling the times method in the fraction class, because this dot A is a fraction, dot times this dot D, which is another fraction. And we do the same thing over here. This dot B dot times this dot C. Now there's still a problem, right? Yep.
For subtracting.
Yep. Good. And is there one? Let's see. Do I have a subtraction method in my fraction class? Because I want to subtract fractions, right? So I should have, what is it called? Minus? Let me search. Oops. I hope that didn't do a replace. I just wanted to find it. Okay, maybe there isn't a minus, but we can add one. Let's go to the plus method. I've done various different versions of this fraction class for various different classes. Actual classes, not Java classes. Classes with students in them. And so therefore, some of the methods are missing. Times is there, times divide, we've got times larger, plus. Okay, so let's say plus. Let's make minus by doing this, just copying and pasting it in the fraction class. Minus, and we'll change this to a minus sign. That's the only adjustment I think we need to make. Compile that now. Oh yes, we still didn't do this. So then dot minus, and then you put all of this in that bracket. Does that make sense? Now it looks like a confusing line, doesn't it? Okay. Now this one, in this case, it might help to take out the thises. It might make it a little bit less confusing. Okay, so let's look at it now. So A, which is a fraction, right? A, B, C, D in this class. Remember, if you go up to the top, A, B, C, D are all of type fraction. A, B, C, D are all of type fraction. So A dot times D, right? So that's just a fraction like F1 dot times F2. That's what we're seeing here. And then minus, and then B dot times C, right? So that part in here. Now, if you wanted to, if that's still confusing, you could go fraction, F1 equals and then go A dot times D, right? And then put F1 here, dot minus, and then do it the same thing for this, call it F2, and put F2 there. So you could do that. But this is a little bit more skillful, isn't it? But they're both the same. Nothing wrong with doing it and showing your work the other way. Yep.
With the fraction one you just did, would it take more like CPU?
Not really, because you're not actually creating a new fraction. So you would just go fraction F1 equals A dot times D. So you would just do that, and then you could replace this all with F1. And so no new fraction is created here in this line. A new fraction is created in this method, but that was there anyway. That was being created here anyway. So, and then you could do the same thing for this one, assign it to F2. Right, so maybe I will do it that way, just so you're not confused. Fraction F2 equals, so A times D minus B times C, right? Trying to remember the formula for matrix, determinant of matrix, and I just put F2 in here. You can call it right diagonal, left diagonal if you want, because you're dealing with matrices. So A dot times D minus B dot times C. Questions?
But I don't want the water.
So now this should work.
Tastes like I'm drinking this.
Okay, so now you can go to your interactions, secondary, or if you want to think of it as the third programmer. We make M1. M1 has these. Now you can compute your determinants. So it should be 1/2 times 0, which is 0. So the answer should be 3 over 4 times 5 over 1. I go M1 dot determinant. When I go M1 dot determinant, it knows to call it from the matrix class because M1 is of type matrix, right? So it goes to the matrix class to call the determinant method. There isn't one in the fraction class, but even if there was, it wouldn't go there because M1 is of type matrix. So I do that, and I get negative 15 over 4, which is true, right? 5 times 3, so I multiply. This times this is 0, minus 5 times 3 is 15, but there's a negative because it's minus from the formula, and 4 times 1, which is 4. And there you have it. So there's our determinants calculated correctly. And again, take a moment when you create a piece of art. You want to take a moment to admire it. This is kind of cool because we've created an object now as an object within an object. We're calling the methods from the fraction class in here, almost like a secondary programmer would. We are a secondary programmer of the fraction class, but we're the primary programmer for the 2x2 matrix class. And that's what object composition is all about, right? And that's how these games are made. Like think of Grand Theft Auto with 1,000,000 cars and buildings and so on, characters. There's so many different things going on. We compose objects upon objects. Once you create one object, you perfect it, then those methods will be called sometimes automatically, like the 2-string ones are called automatically. It just works when you just can focus on your other object. You build objects upon other objects. Make sense? Questions? All right, so what I want you to do now is finish this. There's a whole bunch more methods that we haven't done, like adding 2 matrices, subtracting them, and so on. So I want you to go through your matrix class, save a copy in a new folder, because you're making changes to it. I don't want you to lose your original. So take your matrix class and save a copy into a new folder. Take your fraction class and save it into that same folder, because it does need to be in the same folder if you're calling it. Okay. Then basically change all of these from doubles to fraction, A, B, C, D. Comment out most of the code, and then go little by little, adding each method back in by making the adjustments to account for the object composition. Make sense? It will give you really good practice of understanding object composition and objects in general. Questions? All right, go for it.